All right, so we're set up. We're back up and running. So what we're going to do now is we are going to turn on the power for our GUI. That red button's going to go up. And we should wait for about 1 to 3 minutes. And in the meantime, as we always do, we can reposition this whole unclamping up. Right now this is looking pretty good for our sample, so let's hold. And then let's give it some time to power up. And we can move, for example, let's go ahead. Let's move this to 70. So now we're moving up a little bit closer. So we have right here a sample of 1054 steel. One of the cool things about our, basically our GUI and our video extensometer, we've got this cool toolbox of specimen marking kits and an axial extensometer. So actually we have a real, I shouldn't say real, we have a physical extensometer that we can basically clip to our sample as well. However, why use that one when we can use this one? So I'm going to go ahead, we'll put our sample right here. This is a darker sample, and hopefully it'll pick up the dark contrast. You may want to go, I'm going to actually do something different. I'm going to try white. I'm going to try white on this sample. So we have different gauge lengths. You want to put it at the center of the specimen ideally, which you can just say approximately right here. So center of the specimen, it's 50 millimeters gauge length. I'm just going to basically draw. Ooh, maybe not. Hold on a second. May need another. Oh, maybe not. Let's see if it'll pick up white. This will be a good experiment. And then we'll flip. I'm gonna just put this down, sorry. This is gonna require 2 hands. Go. Hands. So we've got 2 marks on our sample, white, 50 millimeters apart for our gauge length, and we'll confirm that. And so now what we can do is let's set up our specimen. So I'm going to set up the camera. Let's set it up over here. I think we can see. Maybe we can set up the camera over here. Maybe zoom in. Maybe it's better at our original position here. Sorry for moving around on you. But we're just going to grip it essentially in here. So we're going to place it in, close it up, grip, and we'll be ready to go. So we'll see you right after. All right, so I set up the camera and I did power on, and then I did align. So I flipped the thing up first, and then I found the single red line, and then I did test on the bottom. And so now we're going to go ahead and we're going to click our GUI. I'm going to grab a seat. And we're going to do settings, and we're going to do mark detection, and we are going to do detect light, and then we are going to do manual. All right, and then I'm going to drag the inside, the 2 inside ones here and here, and we have a nice signal. And you see here's our initial, this is actually really important. So it's about 47.8 millimeters. So I wasn't exactly 50, but this is my gauge length. So we'll remember that, 47.8 when we gather this data. Excellent. So we can basically save the settings, or actually now we should be good to go. So let's go to our program here. We can minimize this. I'm going to go to new test. I'm going to do static test again. I'm going to do new method, and I'm going to say T1, T1000. Force, we are going to control now based on epsilon 1. It's going to be a plate specimen, it's tensile, but that stuff doesn't matter. So actually we're going to control based on this epsilon 1 value here. So we're going to go, and actually we're going to load again at millimeters per minute. We're going to do 15 millimeters per minute. We don't need a reverse polarity this time. 10 kilonewtons seems pretty fine for me. Here we go. Upper limits. Position hold. Position hold. This will be 100 kilonewtons. This will be minus 100 kilonewtons. So similar things that we've done before. TD2. So we're going to do position hold here, position hold here. So we are going to say, let's say go to, let's go to 80. And let's say the minimum, let's just say -1. All right, and then we're going to do position hold, position hold. Good. So I'm going to say T1. So I'm actually going to go ahead right now. Now this is actually quite useful to have because it's telling me what's my true, what is that displacement initially, which effectively would be your gauge length, as well as that force initially that's applied to it. So actually we can clean up this data a little bit later, and I'm going to leave it right here. So with that, let's go ahead and be prepared for breaking a pretty tough specimen. So let's go ahead and we're going to go ahead and click start. So you can see it's starting to, not quite, but it may neck soon here. Look at our data. Uh-oh, we're starting to neck. Let's see. Oh, you can see it start to neck. Right at that top section right there. You see the neck forming. And boom! Woo! That'll wake you up. And then look at our data. Beautiful. And you can see our displacement in epsilon. And there we go. Fantastic. Great work. Good job, Video Extensometer. And after that, we'll just export the data and we'll get to the analysis. But this is it. This is a cool machine. We will show soon how do you do some fatigue measurements with these bad boy grips here, and then we'll get started. So thanks, see you next time. Bye.